Okay, so let's get started. So this is the last class of this year. I will try to walk through the build process for the actual programs. So I think previous class we try to actually download a lot of things and try to get the code into your local machines and run some commands. But this class I will try to put things together and show if it works, how those things are built. The web extension is basically on the right upper side of the browser, so you can do search and basically create record, search record, delete record. Here is a diagram for the actual doesn't work. There's supposed to be like some kind of diagram. Now for some reason it doesn't pass in correctly. We'll see the next time. So I think on your computers we try to build the web extension in the previous class. So it's we're using the Rust build tools. So we get into the folders, we get into the locations, and we run the cargo command. So this is the output. Like if you build successfully, you shouldn't see any errors. Like those are like warnings for the informational stuff. So this build the target into the target folder. So what actually happened is when we finish this build process, there is output files. I think I mentioned before this is a local-native web extension host. This particular file is communicating with our extension, web extension. So when we put something here, it actually talk to this file, this binary file, which is our executable, and it give back results. So this is the extension part, but there is something missing. It's like, how does this extension know it talk to this particular file? Because this is an arbitrary file on my computer. There must be something like must be something like link them together, because this is an arbitrary file I built. How does this web extension know this file to find when I'm doing something? So there is a concept for web extension called native messaging manifest. But in a simple word, it's a configuration for the browser to find where this file you talk to. So here we have it's called like a manifest, but think it's like a configuration file for this browser to find the host file to talk to. So when you put some extension in a browser, either Firefox or Chrome, it allows you to talk to some other programs, which is an extension. So that's kind of the word extension or add-on or plugin means. You extend the functionality of the main program. So in order for those browsers to talk to the extension, you need a manifest file. And this manifest file determines which file you talk to. So we have an example where this manifest file is. So the location of the manifest file is by convention actually determined. So this part, the manifest file location, is deterministic. It's a fixed location. So the browser actually scan through those configuration files to try to find if I have like any extension to load, so I can talk to it when the extension is actually working. So the location of like Firefox is actually in this path. So it's in your current user folder, .mozilla and native messaging host folder. So if we do a list of this folder, you see actually there is a file. So this is my current user folder, and Mozilla is the company produce Firefox browser. So this is like company prefixed and native messaging host. So this is the configuration path for the file. And now we have app.localnative.json. So this is the application identifier path. If you have a different extension with a different name, you may have a different file name. And we talk about the JSON format. So if we look at it, it basically kind of self-descriptive. Inside itself, there's a path. So this is the important thing. This is where the browser actually locate the location of this binary file we build using Rust. Any questions? What do I see? Sean?
I just got in though.
You got in? So can you repeat what I said?
It was something about like that JSON thing.
Okay. So what does this JSON means? What does this path mean?
Wait, can I see a little better?
Yeah. Jason?
Yes.
What does this file work?
I think I'm probably wrong, but I'm pretty sure it's like describing like the name is of a particular file, the description is the description of the file, the path is where the file is located, the type is just what type of file it is, and then the allowing extensions are just like I guess the websites that you include on the local native thing.
Right. So that will make sense. So what does this path mean here? Yeah, I'm looking at you.
Mean what? The plus?
This path, why this path is significant, or why this is important here?
I'm not sure, but maybe it's because it's like you have to actually have the file on your computer and like.
Yeah, so this is a path, current path, and this path basically give you a file direction location, which is actually here. Local native web extension host 4041 GNU Linux. Is that the same file as this one? Yes or no?
I can't see, your head's blocking it.
Oh, I'll make it larger.
Okay. What file is it referring to?
So we have a path here.
Yeah.
This path.
Mm-hmm.
Is this path locate the same file as this one?
I don't think so, because it's like the first one has extension host. Wait, no. Yeah, actually no. They probably are the same file.
Yeah. So basically this file, this JSON file, the most important part is this path, right? This path tell you where to find this file, which is this local native web extension host version stuff. And actually, it is this file. It is the file. It is a file here. If you look at from the UI GUI view, so we have the path under here, and we have this binary file. So to recap, right? This JSON file give us a path, locate this file, And this file is actually the binary we build from this Rust program, which we use cargo build. Currently, this JSON file tells the web browser, the extension, to talk to that file. Does that make sense? Because every time we open this extension, we do something, it will try to talk to the binary program, because that's a custom program. It's not part of the browser, right? When you install the new browser the first time, the fresh install the first time, it doesn't come with this extension. Does that make any sense? So when you install like a new browser, Chrome or Firefox, it doesn't have all those extensions. It's third party, like if this is like a third party to this program. It doesn't come with no code native in itself, so the browser don't have any idea about this extension at all. When we install this extension, it has the idea of this extension, but it doesn't know where that binary piece to find. So that this configuration tells the browser, if you find a program, an extension name, have this ID, the name is app.noconative, you will try to use this path to find the actual binary program, which is the web extension host. So this host do the major work of doing the search, operating on the database. Does that make sense? Can you repeat?
So when you first download a website kind of thing,
First you download the browser, Chrome or Firefox.
they don't come with extensions.
Yeah.
And you have to like.
And for this particular extension, we have a host component which help us to do the search, create a new record, the type of things, right? So in order for that to work, they need to know the location of that host, which is that file, which is configured in this configuration file, which they call it's a native messaging manifest file. Why it's called native messaging manifest file? Because every time you do something here, it sends a message to the host. And it come back with the results. So it's called it's like talking to the messaging means give something, talk to something and get something back. So this is like every time we do something here, you get something back. So you send a message to the program, you receive something back. So this is kind of the most important kind of the concept for how things work. We have three different components here. The first one is the browser. The second one is this extension UI piece, just this UI piece. The UI piece, I mean the front end, the actual user interface of this thing. But this interface doesn't do the actual work. When we type something, when we do something, it talks to the host binary program, which is actually this file, this binary file, which we build from the using Rust. We build from the cargo build command, and we need to use this manifest file, which is in JSON format, to link them all together. So this name identifies the extension's name, and this path identifies the host binary file's location. So given those pieces, the three components link together. So the browser knows the extension UI, the UI using that configuration file knows the host file. Then they come together. So this is the Firefox manifest file, the location looks like. And then we have Chromium or Chrome. They also have the similar format. They also have the similar kind of the way you put it, but they are from different company. Like the browser from different company. Firefox is from Mozilla, so it has a Mozilla prefix, the location, and Chrome is from Google. But in this project in particular, this file comes at different location. It's at .config. So if we look at that one, so in order for Chrome or Google one to work, like for this to work, the similar idea, but that configuration, the manifest file is in a different location. And this file has a similar structure. We have a path, and also for this we put it. We also locate them to the same file. So one question for you guys: why Firefox and Chrome share the same extension manifest format? Because they are different browsers. Why they share the same format? Okay, so originally there are some differences. Like if you want to develop an extension for Firefox, if you want to develop a different extension for Chrome browsers, it's kind of a little bit different because they are different browsers controlled by different company. But in a while, people want them to be unified. They want standards. They want to develop just once. That's like a less effort. They want to then the same extension, if they have same functionality, to run on different browsers. So kind of a gaming. Once is like one competition. They want to have different standard, different specification, but other ways they also need to facing the reality of developers. Because developers want to develop something just once. If it's the same thing, then they kind of gradually agreed on a set of specification standards. So for most of part, like in the past few years, Chrome and Firefox, their extension become much more similar. So in the end, you can develop most likely the same code will be able to run on those two different browsers. Have you heard the news? Microsoft, what's the browser from Windows?
Bing.
Browser?
Yeah.
No, I'm not talking about search engine. I'm talking about browser.
When I started off with this Chromebook, they started off with it started off with a, what was it? It was like, it's sort of like a Bing. Hold on, let me just search up something right now.
What's the name? What's the equivalent name for Firefox
If I said
or Chrome in
Firefox,
Windows?
Microsoft Edge.
What?
Microsoft Edge.
Yes. So that's the current generation browser. If you, in default, if you directly get a Windows, it's
no, it says I have Bing.
Bing is like a Google. Is like a Google. If you compare so Bing is a Google.
I start off from here and then if I touch.
Yeah. So Bing is a search engine, right? It's like a Google's main website. But the browser, I'm talking about the software for web browsing, the program itself. Google's browser called Chrome, right? Firefox is the program. So in that case, on Windows that's Edge. But before that, do you know what it called on Windows, the browser?
Microsoft Edge.
Yeah, before that, Microsoft.
I forgot the name of it. I remember.
Okay. So I think it's called Internet Explorer, IE.
Oh yeah, hold on.
Internet Explorer, right? Then they change the name to Edge. So actually, develop software is actually pretty expensive, and if you keep, because browser for end users, they don't actually care that much, like which browser you use. Most likely, right? If you're just a normal user, you don't know which you're using. Are you using? If you see here how many browsers I have a Brave, I have a Firefox, I have Chromium, I have Chrome. On Apple, what is the default browser?
Safari.
Okay, good. And what else? How many other browsers do you know?
Google.
Internet Explorer.
Okay.
Somehow there's a lot of kids search engines.
Yeah. I'm just talking about browser, right? So if you think about this, Apple has Safari, and Google has Chrome. Microsoft has Edge. Actually, there are tons of other browsers,
Yeah,
like a different name, different brands. If you think how many developers, like how many people they need to hire to keep the code, to keep them up to date. Can you estimate how many people, let's say for Chrome, how many people full-time job, like a engineer, how many people they need to hire for?
Millions.
Millions, that's a lot.
Thousands.
Yeah, thousands probably that's the right range, right? So if you think about, well, maybe not thousands for a particular one, maybe hundreds, or like depends on which one, right? If you think about all those browsers, you have a huge team to maintain them. Each company, it's actually a huge cost, right? So actually, Microsoft Edge browser is actually Chrome. They actually drop their development, their own development roadmap for the core component. So currently, actually, Microsoft Edge shares the same internal component as Chrome. So they previously have a different like kernel, or they call it like it's a different code base than Chrome. They have but now because it's so expensive and the market share actually doesn't look that good. If you look at the market share for Chrome, it's actually number one for now. It's so expensive to actually just maintain the team and the code. It's better just use the established and mature component. So the actual internal component of Microsoft Edge is using the same thing as Chrome. So that's kind of the cost for maintaining the software. So go back to this extension. That's why you see for Firefox and Chrome, you can actually develop your extension more or less the same, with more or less the same format as their manifest. So that's about extension. Any questions? Okay, good. So we'll talk about the desktop piece. So I think I completed the piece about how this extension is built, right? How the relationship between the browsers and the configuration files and other things. Then I will try to build the. I'll try to get the desktop app running. So we have this desktop app. We are I'm going to run it. See. So this is a desktop app. It looks. What's the difference? What's the difference if you look at this desktop app versus the extension? What's the difference?
The screen is bigger, I guess.
Okay, which one is bigger?
The one that's behind.
This one?
Yeah.
Okay, that's one difference. What's the other difference?
It has like that stop on the side.
Stop?
Like on the right.
On the right. Okay. And the other difference, other notable difference.
Those bar graphs.
Okay, so those are some kind of more graphic components in this desktop app, and so we can also do some kind of search. It kind of trying to filter. Okay, so what are other differences? All right. So the major difference, yes, those UI things. The major difference is this is a standalone application. This is not a extension or plugin or add-on. So for browsers, like when we're doing extension, right? It's part of the browser. Like you add on a small functionality to the browser, but this browser is not your program. It's another program already exists. You just add a functionality to this browser. That's why it's called extension, right? What does that mean? Is like it's extension. It's a small part of functionality you add to the browser. And this program is standalone. What does standalone means?
It comes out the whole entire page. It's not like an add-on.
Yes.
Yeah,
So
it's just itself. It's its own program. It doesn't need anything to base it off.
yes. So that's the biggest difference. Is like, so the binary. When I run it. It starts itself. It doesn't need a browser or doesn't need anything. So it itself, it's a program, self-contained program. It's standalone. When you start it, it has its own UI. It actually has its own complexities for showing the scene, reading the database, doing the search, and other things. Okay, so I will talk about a little bit more about the structure of this desktop program. So this desktop program actually using the same technology as a Chrome web browser. So you look at those things; those are built more or less the same way as a web page. If you play with your browser's developer tools, so in particular, if you toggle developer tools, you will see. So if you still remember something about HTML, you will see those user interface component. Yeah, you see those pieces. If you still remember those tags, like container with a container type of thing, you see everything of those like buttons. It's actually their code is actually work like a page. So if you look at this whole UI on the left part, so this piece is the developer tools. It shows the structure of this graphic interface. But if you look at them in the code, they actually, like when I scroll down each of those components, they correspond to a particular HTML component, right? So this is the whole body, the whole web page, the whole UI, and this is the left part, navigation part, and this is the middle part, the charts and display, and then we have the right part, which is those tags. So this is the HTML in action, which they actually share the same web technology to build the UI. So even you don't see a browser here, you see web technology in play. So that's why people saying doing web development, why people learning those skills, why people doing website, it's like it's a skill not only for develop like a web page or website, it's also like a skill for actually develop those kind of UI tools. If you are, so it's kind of transferable skills for doing graphic UI work. So you can not only build a website, but you can also build graphic applications with HTML and those things. Okay, so let's see some actual code. We have the actual code for the whole project here. We have the browser extension folder here. I think I touched briefly. And I showed the pop-up, the code, HTML pop-up, which is the browser extension piece. Like this one, the build with HTML and things. So that's a corresponding code. For the desktop part, it's under local-native Electron. So what does Electron means? So Electron is a framework for this type of graphic applications. Like I said, you are using HTML, you're using web technology to build a graphic desktop UI application. So this is called a framework, or like a library to build cross-platform desktop apps with JavaScript, HTML, CSS. So this is a pre-packaged tool set for build graphic interface applications on different desktops. That's why like our class called cross-platform. That basically means we actually using those cross-platform tools to build on top of it. So Electron is a so-called open source project, or a common framework to build this type of things. And so our project is built on top of this. So this framework actually using the same code the Chrome browser is using to render the graphics. Like I said, like Microsoft Edge is using the same code as Chrome browser. So this is kind of the same thing. They use the same code for rendering, so for displaying the graphic interface. So you see a lot of similarities. Like they actually have the same developer tools on the right. Like these developer tools have the similar sections when you open the Chrome browser's developer tools. So you see they actually share the similarities as developer tools. So in short, you can think about this is actually a browser, like sort of. This is actually a Chrome browser in itself, but packaged in a way to display your application. So that's the desktop part. And I talk about the Electron. And I will show the rendering. So a little bit. So how do you think when you see a web page, how it's actually displayed? Like there are so many, if you look at the web page itself, there are so many components, like one inside each, one inside another, one inside another. But how does it know which one to display piece by piece? So this is the word rendering means. Rendering means display something like in order or something, like how to actually show it to the user. So there are some like a diagram to saying what actually happens when you see a web page. You have different components talking to each other to decide how to display, how to lay out, how to show things. So for browser like this, it has a complex pipeline to show each component to do like layout calculation, what image or what text put where. So that's pretty much everything you show on a screen goes through this process. For browser, it works like this, but for desktop application, you show some windows. You have different windows on display on top of each other. It's also kind of doing a similar thing. Calculate who is overlapping with what, which one to show first, what is the background, things like that. Okay. Then there's another question, right? We have this standalone application. We have this particular like search box to show things. We can do some kind of filter on this. Do you think we share the same code when I do a search query here for the browser extension, and if I do a search query here? What do you think is happening? Do we share the same? Does it look similar? Are they look similar functionalities or the same features? Yes, no, no, yes. If I'm searching something here in the desktop application versus I'm searching using the Chrome extension.
I guess, yeah, they look different. It's just that
They show 10 results. They show results here, and like if I do query, they show like this is the first query, second query. This is the first item in find, second query is find, and you see the results are kind of are the same. The first one is this Oracle SQL, Graphic SQL, and this one, if I do like a query, the results are pretty same. So, do you see correlation between those? Do you think they are the same thing or not the same thing?
I don't think they're like the identical same thing, but I do think that they probably like share off similar things.
Yeah, so that's actually exactly the right answer. They share the exact same thing to query the database, but they do not have the exact same graphic interface, right? Because this UI definitely, like, this is a standalone application. The layout of the thing is different. The content to look back is the same. So that's back to the last class. We talked a little bit about the database and SQL. They both look at the exact same database, this file, locally database. So we're talking about database files here, right? So this file, I think last time I showed, we can use the database browser to actually see the content of the database. So in this database, we have the node. It's called a table. We have a node table. If we browse this node table, you see all the content, like all the record for this node table. So actually, all the queries is trying to query this node table. It's trying to find the text. If you have anything matching those record, it return back to you. So in that particular case, we search like what contain a query. So it goes through the record and try to see if queries that particular characters or text appear in those record and give back those record from this table. The table means each record is a row, and every column is like an attribute on the row. So every row basically say, I have this title, which is the title of the web page when you bookmark it. This is URL, which is where the URL comes from. And we have the tags. We also have the timestamp of the creation. So when we doing the layout, when we order this thing, it's kind of ordered by time. So the latest one ordered on top. So it's actually a small kind of search engine on top of your own notes, bookmarks. So everything we do here, it's actually searching the database. So the database is a file in this particular case. We talk about this binary file, right? This extension is an executable. It's called an executable file. Executable means it's a program. It does something. It actually, if we give an input, it gives us output. But this file, this SQLite 3 files, Postfix file, it is a database file. If we look at this file, we're using this program. It gives us a look at the data. If we look at them actually in plain text, what if we just look at them as raw as it is? It's actually the content. Like you see, there are some HTML text inside the file. Some of them are random, like unreadable. Some of them are readable. The readable piece is actually a text. So this file is a database file. This is a database to store our notes. Currently, if you look at them just as text file, a lot of actual plain text is in them. So we kind of glue all those different components together now. This is a standalone application. When we do queries, it search the database files, which is here. When we do web extension, when we do queries here, it also searches the database file. It's doing that by using the binary executables. I think that's it.